have the atomic mass. So it's actually like 2 times the atomic number. So that is what the atomic mass is, 2 times the atomic number. Roughly, not accurate atomic number. So if you check the elements, so each of them, when you get to the atomic number, just do times 2 of it. It's likely that you get the mass number or the relative atomic mass. I'm not seeing them interchangeably used. Now, instead of doing 2 times the atomic number to get the rough estimate of what the mass number or the relative atomic mass is, the equipment that is used to find the relative atomic mass or the relative atomic number is what we call important mass spectrometer. So with this mass spectrometer, you can actually measure the relative atomic mass and get the actual number. And that's why you're able to get this. So this I actually got from mass spectrometer. And why we have them in fractions is that most atoms actually have isotopes. So they have isotopic forms, 2 different forms existing with the same atomic number mass or different atomic masses. So because of that existence, we have this. And previously, the reference point for checking the relative molecular mass, it was actually hydrogen, because hydrogen has that of 1. So the one that have, because hydrogen is the lightest element. So every other element has mass that is heavier than hydrogen. So they were all calibrated with hydrogen as the reference point. But in modern time, that we are now using mass spectrometer and observing the fact that there are isotopes, we are now using carbon as the reference point. So with those two into consideration, you can say that the relative atomic mass, AR, relative, R stands for relative, A is atomic mass, of an element is the number of times the average mass of one atom of that element is heavier than 1/12 the mass of one atom of carbon-12. So the relative atomic mass for hydrogen is 1.008. That of oxygen is 15.99. So you can easily say that the mass number of oxygen is actually 16. Now, the relative molecular mass, when you're talking about molecular mass, you're talking about compounds. The relative molecular mass of an element or a compound is the number of times the average mass of one molecule of it is heavier than 1/12 of mass of one atom of carbon-12. So this carbon-12 is actually the isotope of carbon that is used as the reference in these calculations and using mass spectrometer to measure. So for relative molecular mass for calcium triazocarbonate, so if you want to calculate this now, you have Ca. The relative atomic mass for calcium is 40. So there is only one calcium, only one molecule, so you have 1 times 40. Carbon, the relative atomic mass for carbon is 12. You know the mass, the atomic number of carbon is 6. So the relative atomic mass is times 2, which is 12. But since there is only one carbon atom, you have 1 times 12. Then the relative atomic mass of oxygen is 16. As we have here, 15.99, approximately 16. But there are 3 atoms of oxygen, we have times 3. So when you multiply out and add up together, we have the relative molecular mass of calcium triazocarbonate to be 100. So that is how you do this calculation. Very, very simple. So you use this 100 in your calculation. So calcium carbonate, the relative atomic molecular mass is actually 100. So that's how you calculate relative molecular mass. You add up the individual elements that are involved for a compound. Whereas relative atomic mass, just write straight down the reading from the mass spectrometer. So these very quantities, we are going to be using it a lot in calculating. Note, you can also hear this, some people call this relative atomic mass, mass number. This also mass number.